Hello, pre-calculus type people. I hope you're having a fantastic day. It's a beautiful cloudy morning here when I'm making this. Sun's not up yet. Mildly depressing. But hey, I've got the light of pre-calculus to warm me. So that's a good thing. Writing polynomial functions. Alright, so we are going to use the information given to write a polynomial function and sketch a graph. So we're going to be multitasking here a little bit. Alright, so we've got a couple of things that we need to remember. Number one, we need to remember everything that I ever taught you about roots. Now, these can be single roots. Remember, we talked about this yesterday just as a review. They can be single roots, they can be double roots, they can be triple roots. So a single root crosses the x-axis. A double root, A double root is going to bounce off the x-axis. It's going to go down and bounce off, or come up and bounce off. And a triple root is going to cross and change concavity. Right? It's going to cross and change concavity. So let's look at one of these here. Number one. Perfect place to start is number one. We have autonomous polynomials now. I am a cubic with a double root at -4 and a root at 0. The point 2, -36 is on me. Write my function in polynomial form and sketch me. Sketch me! Alright, this is not as difficult as it may seem. I'm going to underline the important bits. I'm a cubic function. I have a double root at -4 and a single root at 0. So first things first, f of x. Now the only thing that we don't know about this function is some value of a, so I'm going to put that in here. And it says I have a double root at 4. Well, a root at 4, a single root, is x minus 4, right? Because if you set it equal to 0, you have x equals -4. Ooh, plus 4. Woo! Nearly messed that up. Set this to 0, so add your 4 over. You have x plus 4 equals 0. And that's what makes a root. So it's x plus 4, and that's a single root. So to make it a double root, watch very carefully. Double root. Square it. And a single root at 0. X equals 0. So that's just x, right? Now, the only thing that we don't know about this is a, and that's why they've given me a point. I'm going to plug this in for x, this in for y, and figure out what a is. -36. And that's 2 plus 4 squared times 2. -36. Let's see, 2 plus 4 is 6 squared is 36 times 2 is 72. Big numbers. Well, divide by 72 and you have a is -1/2. Okay. Now that is very important here. Remember that a determines where the right hand side opens. So I'm going to put a little star beside this and I'm going to say negative leading coefficient. Negative leading coefficient. That means I'm going to have an x-axis reflection. Abbreviations everywhere. Let's rewrite the function. F of x is -1/2 from right up here. X plus 4 squared times x. Now, we could actually go through and multiply that out, and it's perfectly fine to do so. If you do that, just x plus 4, you know that this is -1/2, x plus 4 times x. Foil out your x plus 4s first, then distribute your x, then distribute your 1/2. You end up with f of x is negative 1/2 x to the third minus 4x squared minus 8x. I know what you were saying. That's too much. No, it's not. We are big boys and big girls. We can do a little algebra every now and then. So let's figure out what this thing is going to look like. It's a cubic with a double root at negative 4. 1, 2, 3, 4. 1, 2, 3, 4. Never label your y-axis. Never label your y-axis because that's going to make it right or wrong. And I don't want to label my y-axis because I don't want to be that accurate. But what's important about this, my leading coefficient is negative. See this negative 1/2 right here? That's my leading coefficient. Now I've got a double root at negative 4 and a root at 0. That means that on the right side of my far right root, I'm going down. Now it's a single root at 0, so I'm going to cross. Right? Still go in the same direction, same concavity. And then a double root at 4. Now this is cubic, right? It's a cubic, so that means if the right side is going down, the left side is going up. And I'm going to touch and bounce away. Simple as that. Touch and bounce away. Alright, next one here. Says write a polynomial function for each of the following graphs. And it says it passes through the point negative 1, 12. Negative 1, 12. Okay, well first I need to come up with a couple of things here. I'm going to list all my roots. Looks like I got a root at negative 4, negative 3, and 1. Now let's look at what kind of root they are. Negative 4, it passes through and it's concave up on both sides. Negative 2, it passes through and it's concave up on both sides. So those are both single roots. Positive 1, it passes through and it's concave down on both sides. So single root. So negative 4, negative 3, negative 1. So again, it's a single root because it hasn't changed concavity. So let's set this up here. F of x is your a value. This will be x plus 4, x plus 3, and x, that's supposed to be a positive 1 right there, minus 1. Apologize about that. So plug in 12 for y and negative 1 for x. Negative 1 plus 4, negative 1 plus 3, negative 1 minus 1. Alright, so this is going to be 3 times 2 times negative 2. 3 times 2 is 6 times negative 2 is negative 12. So a is negative 1. So let's plug it back in. F of x equals negative 1. X plus 4. X plus 3. X minus 1. Now again, that's a perfectly acceptable answer. Perfectly acceptable. But if you wanted to multiply it out, you can. You certainly can, just so you're aware. What you end up with is negative x cubed minus 6x squared minus 5x plus 12. So the question would be raised, well, how do you know if you have to FOIL it out? How do you know if you have to multiply all these things and distribute and do all this stuff? Here's how you know. If it's a multiple choice test and it's FOILed out, distributed out, then you have to FOIL and distribute. Ta-da! If not, don't. Save yourself the work. All right, a couple more here. Number 3, passes through the point negative 2, negative 24, write in factored form. Now see, this is specified, write in factored form. Oh, you know what? I think the other one specified write in polynomial form. Oh, well that's also how you know to do that. Write in polynomial form. So multiply everything out. This is actually the answer. That's only on there to make sure you know how to do it, right? And you know how to FOIL. FOIL this out, FOIL that in, multiply by -1. Gina, I'm making a video! Sorry about that. So number 3, passes through -20, blah, blah. Write in factored form. So good, I get to leave this one alone. That's what I get for not reading directions. So first, zeros, also known as the roots. All right, so I've got passing through, not changing concavity, so it's a single root at -3. Work my way to the right. Double root at 2. And looks like a single root at 4. I know that because it doesn't change concavity. It's concave. I could forget about the rest of the graph. It's concave up right here. It's concave up over here. That's all I care about, right? So let's get this thing set up here. Now, from the looks of it, and some of the stuff we talked about yesterday, we have 4 roots, right? 1, 2, 3, and 4. And both ends are going up. So this looks like it's going to be a quartic function, doesn't it? Power of 4. But let's keep that on the back burner for now. F of x equals a. This is x plus 3. X minus 2 squared, because I've got 2 of them, and x minus 4. Okay, so let's plug in our point here. We've got a -24 for y and a -2 for x. Do a little math. Do a little dance. Do a little math. Get down tonight. This will be 1. Yay. -2, -2 is 4, so we've got 16, 4 squared. 16 and positive 8? Positive 6, excuse me, -6. What am I doing? Let me write this down. This is 1. This is 16. This is -6. There we go. And 16 times 6, you all know, is -96. Take 16 times -6, excuse that. So we divide out 24 and 96, we get 1/4. So your function, 1/4 x plus 3, x minus 2 squared, x minus 4. Please don't forget to put your x's back in. Don't forget to put your x's back in. I've had so many people, for some, just not put the x's back in. And I'm like, why? The answer's so simple. Just put the x's back in. Okay, let's go down to number 4. Start off with my roots. Remember, I'm doing it in factored form going through this point. So I've got a root at -4. And, ooh, surprise, surprise. See how this is concave up over here? It looks like a smiley face. This is concave down over here. It looks like a frowny face, sad face, right? Smiley face to frowny face, that's a change in concavity. At -4, that means we have a triple root. Triple root. And then we've got a root, looks like a single root at 1. So I'm going to have f of x equals a, x plus 4 cubed, x minus 1. Plug in your point, -162, a, -1, plus 4, cubed, negative 1. What am I doing? Close enough. Good grief. Negative 1 minus 1. Okay. So this is 3 cubed, which is 27. And times negative 2. 27 times 2 is 54, negative 54. Divide by negative 54, and you get A is 3. F of x equals 3 times x plus 4 cubed, x minus 1. And there was great rejoicing. Yay.